And the cache resolver, it has three major components: the actual cache machines, the user browsers, and the domain name servers. And the caches: a proxy cache replies with the data if it has a valid copy stored, or it fetches the data from the original web server and stores a copy as well. And there's something which we use as, it is called a squid. So when the squid is alive, the load, it represents the byte transfer rate at which the cache serves its web request over the last 30-second interval of service. So Squid uses a LRU replacement strategy for load balancing and failover purposes. That will be we ran additional software on the same physical machines as the caches that monitors the Squid process. And moving on to mapping to caches. To implement browser's consistent hashing, our first hope was to exploit the auto configuration function present in most commonly used browsers. So users, they can specify a function written in JavaScript that will invoke every request and will select a number of proxy caches to be contacted based on the URL string being requested. So unfortunately, the auto configuration is too limited to support consistent hashing. So the fundamental problem is that the auto configuration script is downloaded once manually. So the proxy the set of the proxy caches change, the mapping function would become incorrect. So in order to get around this problem, we decided to use the DNS. With the DNS servers, if we could set up our own DNS servers and modify them to support consistent hashing. The DNS servers. The primary function of a DNS server system is to resolve the virtual names generated by the users and decrease the memory that was used in the caching. The JavaScript generated by the user's JavaScript function to the actual physical IP addresses on the caches. The large number of virtual caches means that each will receive only a tiny fraction of the total system load. So consistent hashing guarantees that number of virtual names assigned to each cache will be evenly distributed among the caches because of the use of the DNS. These two facts, they together ensured that the page load is uniformly distributed over caches. And discussion. The DNS is a standard tool for locating objects. We are using it that in capacity instead of going to the effort of implementing our own protocol. So DNS is used only to create mapping from a set of 1000 names to IP addresses. Thanks to the properties of consistent hashing, the entries don't even need to be particularly updated. And the test and test setup. Basically, we compare our cache resolver against two types of such systems: the Harvest system and the Crisp. And we believe that our design would give us a better performance than the existing web caching system we studied. And to test our system, we used a network of 7 machines connected to a 100 MB switch. 3 of the machines ran Squid and the proxy cache program. Another machine was designated as a web server and was placed on a 10 MB link in order to make data transfer with the web server costly. And the test driver. We generated a database of 1500 files of varying sizes with a total size of 34 MB. The number of clients each running a specified number of threads is specified on a surge as an argument. The surge then simulates those clients that together go through a request schedule that the search creates. We run search with 3 clients where each client talks to its own proxy cache. So finally the results, we ran the test to compare the cache resolver with the common mode under the various proxy cache configurations. Then we analyzed proxy logs to compare miss rates for different test runs. We varied cache capacities from 9 MB to the 36 MB. Since total database is 34 MB, caches with smaller sizes will have higher missing rates because the 9 MB is very little compared to the 34 MB, and data could be forced out of caches with LRU. The difference in these miss rates is even higher with the smaller cache capacities, where the data duplication of the common mode has even worse effect. So concluding it, when the user is responsible for knowing which cache has the appropriate data, the significant penalties in the critical loop of a user request can be avoided. This knowledge can be provided to the user with a hash function. Through the efficient use of caches, consistent hashing can significantly improve the efficiency of the World Wide Web. Thank you.